Hi all, good morning, good afternoon, good evening, um, my friends from different time zone. Today we are going to learn one of the hottest topic in the market, Snowflake Cortex AI. Basically, it is an introduction to Snowflake business intelligence uh, from the Cortex perspective. As we know, Snowflake is a cloud based data warehouse used for data and analytics platform, and it has many new features which distinguish it from our legacy data warehouse systems like Oracle, SQL Server, etc. So, in this particular video, we'll try to restrict it to know what is Cortex AI and what are the different kinds of benefits we are going to get, and also we'll try to cover some hands-on at the end of this slide. So once again, welcome back. My name is Kiranjit, and I work in an MNC for last 12 plus years, and I am having experience particularly in the area of data warehouse, architecture, and intelligence. So let's get back to the topic. So, uh, this slide I have prepared it from Snowflake's documentation. So, nothing I have taken from my own. It is, if you can see, I have given reference below uh, where you will get those information. So, coming back to the Cortex, what is the Cortex? And why Cortex is now integrated in Snowflake? What are the benefits and what are the features and how we can leverage it in our day-to-day activities? See, the main intention of covering this topic is because I have gone through Snowflake documentation, I've gone through Snowflake internal videos, but I do felt a problem like getting a proper curriculum and a proper start guidance so that all of the IT people or any student who are working on this Snowflake should get a proper syllabus to go with and get adequate knowledge. So that's my intention. With that intention, we'll start here. Cortex, Cortex is nothing but giving a AI and ML, artificial intelligence and machine learning capability within Snowflake. So before coming to Snowflake, if we go and see around AI and ML, we would see lot of Python libraries, we will see lot of utilities, Anaconda, and different tools to work in and create libraries or packages which can be beneficial for our society, like creating a anomaly detection model using some Python libraries and then deploying it into production so that it can be really useful for detecting any abnormalities or anomaly or in the field of um, security, right? It can be used, but the the main challenge in in that area is like you have to integrate Python or any common core library which can be used for machine learning and artificial intelligence on a database, because you need lot of data to analyze. You need lot to lot terabytes or hexabyte of data to have proper prediction model, because the more you have the data, the more accurate is your prediction. So definitely, uh, when any companies will think of using this model, AI ML model, into their data, they are quite reluctant, because nobody in this world or no company in this world wants to share their details with other vendors or with other companies. See, Snowflake is one of the company, and when Snowflake is used by any manufacturing company or banking sector company, then the bank or the manufacturer don't want to share the information to Snowflake, right? That's the everybody interest, and that's where Snowflake comes with. They have a guardrail, they have a um, um, proper boundaries out of which the data never goes out. They make sure they have their bread and butter. They want to make sure that this should be work within the frame. So that's the reason Snowflake comes with a solution like, hey, you don't have to go outside and connect any Python tool to your data, right? Nobody wants to connect open source technologies with their data to play around. By that, there might be a chance they are exposing their data to the outside world. So that's the reason Cortex is nothing but a utility or a feature which is available within the Snowflake to make it AI ML ready. I would rather say it's a AI ML ready feature available within Snowflake called Cortex. If you look at the architecture here, you'll see it has agent APIs, apps, multimodal AI powered SQL, unstructured, structured document processing, um, many agentic insights you will get in this area. Below, you have your data hosted. It may be externally stored, it may be internally stored, it might be present in some external storage so that we can bring them into the Snowflake by using any of those open flow technologies. And on right side, if you see their model and governance, and particularly in the models, you'll see a lot of models we have. So this gives us a added advantage of using OpenAI, Anthropic, Meta, Historical AI, DeepSeek. Lot more models are there, so that we will get a fine-tuned, refined version of output for our research and analytics, right? And nevertheless, governance always comes at the first, because this is the place where your actual security and proper way of working with the data has been ruled here. So if you can see, this entire frame, this entire architecture of Snowflake AI Cortex works within the same model like Snowflake works, like row based access control model, so that you have, if you have proper roles, you can work inside that. It has proper guardrails to safeguard your data, allowing not to go outside the proper boundaries. It should work within your data frame. Evolutions, see, your data frames are coming with some evolutions, are always evolving and are always evolving with new features. So that's what Snowflake Cortex AI makes sure your framework is evolved uh, uh, with a time frame, right? And then monitoring. So monitoring is the place where your operations has been carried out and you want to see how the deployment or where the application has been stopped, or where the pipeline has failed. So those things will be monitored quite well within the Snowflake. So you don't have to go outside the boundaries. You have to work within the Snowflake. And if we see here in the middle, there are a lot of models, so that gives intense confidence, like we will have a lot of models to work within, and we can use them to fine tune our model. Okay, so before we go into the machine learning, this course will be having a tight scope of covering the AI intelligence model. So we will cover here the Cortex LLM functions, because the ML part will tell more on the prediction side, more on the forecasting, more on managing or training any model. That is out of scope from this course. So with this, let me go to the proper definition. So what is a Snowflake Cortex AI? I just wanted to show you uh, the architecture, a pictorial architecture, before we are coming over any definition. So this definition I haven't taken from my own mind. It has been collected from the Snowflake documentation. So it offers two broad categories of powerful intelligent features called AI and ML. These features can help you do more with your data in less than ever before. Cortex is suitable for predicting or not for forecasting. It is generally used to provide insights from your data. It has a wide range of suits which leverage or which gives more advantage of having AI features over the large language models. So what is the large language models? If I tell in a layman words, large language models or LLM models are generally are deep learning algorithms, and there are many LLM models like Llama, Meta. So Llama is a LLM model from Facebook Meta. Um, as well, there are Cloud A. So there are a lot more LLM models in the market, and Snowflake has also integrated all those things within it. And these all features make the Snowflake more intelligent and more robust. Setting up the stage. We'll first try to set up the stage where we will utilize synthetic call transcripts data. So thereby we will mimic this text sources commonly overlooked by organizations, including customer charts, survey interviews, and other text related generated marketing and sales team. So here we have a data of call transcripts where a call center data has been provided. We have the sample. Let's go and deep dive and see how we are going to use this cortex in our day-to-day activities. So these are the basic steps where we are going to create a database, schema, warehouse, create a table, load sample data from Amazon S3 bucket. So there's a steps which we'll try to go with. Okay, so these are the piece of code. Anyhow, we are going to apply this in our hands-on, which we will cover in later after this PPT. Task-specific LLM functions. So basically, uh, Cortex has two things. One is um, Cortex an analyst, and another is Cortex. Um, Let me go back to here. Cortex search. If you see Cortex analyst and Cortex search, these are two different things. Cortex analyst work on the structured data retrieval. Cortex search works on the unstructured data retrieval. But both are inside this agents and insights. Okay. So whatever we are going to use the LLMs, that might be from Cortex uh, search or Cortex analyst. So basically, the parent will be Cortex, the child will be search and analyst, right? So we'll use the functions from Cortex parent itself. Let's go back to um, the slide where we can see there are specific tasks which we are going to operate. The first one of the task will be like translating any models. Translate means it basically translate any text from one language to another language. Let's see how easy it is to use these functions. So this is nothing but, if you see, select snowflake.cortex.translate, and here we have passing some text which is basically in German language, and we are going to translate into English. And if we want to use it in a bulk mode or a batch mode on a table specific, suppose we have a table and we have a column called transcript column where we have all the informations available in German language. So then in that case we can just pass that column name instead of text, and rest syntax is same as it is. Sentiment score. So we have started this LLM functions to primarily make use of Cortex in a wider and practical way. First we covered translate, and second is your sentiment. Sentiment is nothing but it is used to analyze the customer sentiment or behavior, so that we can have a better idea like how we can improve our customer satisfaction, and how we can better provide the service. Generally, if we have the sentiment score with us, we can decide next like how we are going to improve ourselves. Basically, this score will be in the range of negative to positive. 0 stands for neutral, and 1 is positive, and negative stands for most negative. So this is the range minus 1 to 1, minus 1 to 0, and 0 to 1, where 1 is positive and minus 1 is most negative. 0 stands here for neutral. Here, if you see, if you are passing a transcript, so this transcript has billions of records. Let us say billions of records are stored in a column, and each record is something called is not in a structured format. This is unstructured data, is a called transcript. So all your conversation of the calls will be stored inside that column. So if I go and ask you, like, please go through each transcripts and tell me the sentiments behind. So what you'll go start and reading all those transcripts for each transactions, and then you decide whether the sentiment is positive, negative, or neutral, right? So it is a very tedious task, and not possible if we are going through billions and billions of records, right? So in that case, Snowflake provides a uh, uh, a very powerful Cortex function called sentiment, where we have to pass that transcript column here. If you see, select transcript comma snowflake dot cortex dot sentiment transcript from that table, where language equals to English. So just try to restrict yourself, because we are going to cover this practical after covering this slide. We'll see how we are going to translate, how we are going to analyze sentiment. Here another LLM function is nothing but a summarize. Summarize is nothing but, if I have a paragraph of text, um, I want to have important points out of this paragraph, so that I do not want to spend my entire time going through pages and pages of um, informations. So rather than, I prefer to have a summarized version, so that I can get my so that I can analyze quickly. And this is where you could have seen in your meeting, Copilot will be summarizing your meeting of the minutes, and that's how it saves our time. So Snowflake also provided us snowflake.cortex.summarize functions, so that we can uh, go and summarize a particular informations available within the column. And if you see this LLM functions, definitely they have some charges. If you are going to translate, if you are going to summarize, if you are going to understand the sentiment or make use of sentiment functions, definitely they incur some compute charges or cost, I would say. And that cost is based on the number of tokens used or processed. So the token is nothing but the smallest chunk or the smallest piece of information that has been processed. Usually this comes with 4 characters to 1 word, which mostly referred as a token. Okay, this is one more LLM function we'll see, classify text. So suppose you have a bulk of information and you want to classify them, like what these informations are related to. So you provide a list to Snowflake, like whether the information you see in the column is a travel or is related to cooking. Then Snowflake output will give you it whether the sentence written or whether the column has been passed here is related to travel or cooking. So this is the area where where it solves the classification problem, as you must have read in your ML learning, classifications, supervised, unsupervised, right? In unsupervised, mostly we go for classifications kind of thing. Yeah. Okay, prompt engineering. Prompt engineering is something more related to when you are going to use Grok, OpenAI, right? ChatGPT. You provide some prompt and it will give you some suggestions, some good articles related to that. So similarly, in Snowflake also we have the similar feature called complete. So Snowflake Cortex complete functions come with this feature, where you pass a string as a prompt, and a Snowflake Cortex complete function will give you the best to best um, text. It's mostly a generative text, where you are generating some text and giving it. And here we have used some model. If you can see, cloud 4 model has been used. So it depends. So again, the billing will depend on the model you are been using, whether it is a GPT-4, a cloud, or Anthropic, any model you are going to use, right? Okay, so coming to Streamlit, what is a Streamlit? Basically, it is a application where you can bring your data live in the UI. So imagine I asked you to um, go over a bulk of data, to analyze tons and tons of data, and prepare a dashboard where you can choose something. I mean, you can choose and see the charts working on those data, right? So what you'll do, you go and apply some Python framework like Django or Flask, or you go for any .NET application, or you go for a Java application. You create it and embedded this code within it, so that it can analyze and provide a business intelligence tool. But Snowflake has a internal tie-up with Streamlit, so you don't have to worry about that. You just call Streamlit library, and it has a bulk of features available like drop down, checkbox, right. You can have a header, you can set the output layout, you can have a text area, you can have many things. It has Streamlit. So Streamlit turns data and artificial intelligence into interactive apps within the Snowflake, so you don't have to go outside it. And that's make it perfect feasible way for our data engineers, mostly who works on data side. They don't have adequate knowledge on front end, like Angular or any of the Python framework. They don't have that knowledge. They can quite leverage this Streamlit application for making any um, um, application which works within the data available inside Snowflake. Okay, so if I show you the output screen, this the Streamlit application just look like this. The left side we have the code, right side you can see it comes with a header, with a text box, and if you click on the summarize, it will just give the summary below. So if you can see here, the summary is here. This is the output of this code which is in the left pane. Cortex cost. So basically the cost basically depends on the function we are using. As I told you, the number of input and output tokens processed. Yeah, similar thing. Token is roughly 4 characters to 1 word. Think of token as the smallest unit of text or chunk. Each Cortex function uses an LLM model under the hood. These models have been associated for 1000 tokens, and it varies depending on which function you are calling, where you are calling, I mean which model provider you are using, or whether it's a general task or a fine-tuned model. Fine-tuned model is not covered here. In general task we will be seeing like summarization, sentiment analysis, classified text, translate. These are the general tasks, right? Fine-tuned model we are not going to do, because by using this general task LLM functions, we are not going to train your model. We are using already trained model for our data analysis. Okay, with this, I think all slides are covered. If I go to Snowflake, let me open it. Give me a second. Let me open Snowflake. See, understanding Snowflake is very simple. If you have a background of SQL knowledge, then definitely you can go sign up, and I suggest you to go through Snowflake documentation and start working on the dashboards, or start working on the worksheets. I strongly suggest you to do your hands dirty, because without practice it is very difficult. Let me create a SQL file. So if you can see here, So here, if I apply, let me just copy and paste the codes. So my code is here. So I'll be using all those features so that it will save some time. So okay, you can see we are using account admin, and then we are creating a database called DashDB. Um then I'm creating a schema called dash schema, and then I'm creating a warehouse dash underscore access underscore wh, and where I'm defining my warehouse size to be extra small. Using the same schema and database and warehouse, I will create a file format. I hope you will be having this knowledge, or else you can go and check the um, file format options available in Snowflake documentation. It's not that much difficult. And then after creating a file format, we are going to create a stage. So after creating the stage, we have the call transcript information available. So let me create a table and copy the data from stage to the table, right? Okay, so here I am creating a table called transcripts, where I have 7 columns are there, defining date of creation, language, country, product, category, what are the damage type complaints available, and the call conversation inside transcript column. uh, okay, let me copy the data from the stage to transmit. Okay, I haven't run this table. One second, I'm getting some error. um, what happened? Okay, might be it's because of copy and pasting the things, copy paste issue. Okay, now it will be created, and now I'm going to copy the data from stage to call transcript. So let's see what are the types, what are the um, records or the data available within this table. Limit 10. So if you see, just I'm trying to collapse this window. Okay, so if you see here, it has date created, language, country, product, category, damage type, transcript, as I told you. So each call conversation is being stored inside the transcript column. And if you see here, these are basically the structured data, but this, when it comes to the transcript and the conversation, it is mostly a unstructured data. If I double click, I will get the complete data here. Hello, in some different language, I could see it's mostly in Germany or French. Yeah, so we'll go through, we'll understand how we are going to analyze it. So if I run any cortex function, select star, um, sorry, so there is a column called transcript, so we will use this. Oh, my mistake. Transcript. So here we'll use the function called translate, and here we'll give the transcript column, and here we'll pass. So we only want to translate the values wherever we have German language, and here I can just pass where language equals to, let me just check, language is German, and with limit 1 or 10 or 1, let us see. Okay, cortex, so we should use snowflake dot cortex dot translate function. And if I show you the output, just now, okay, let me just collapse this and expand this. Okay, it is saying request failed for external function. The model you requesting is unavailable in your region. It access enable To access it, enable cross region inference with AWS APJ. Okay, it is saying like in whatever region I have chosen this compute or compute instances, that for that reason this function will not work. So let me just take this how to enable this inference and just search it in Google. I'll get it definitely. Cross region inference. So if you can see, inference is the process of using machine learning model to get an output based on your user input. So I could see, let me just do a alter account cortex enabled cross region to this. So that means it it is saying me in this, but the region where my Snowflake is hosted is not supporting this particular function. So let me do this alter account and it's successfully done. Now I'll run this. So if I see the output, you can quite see it is in German language and I have converted it to English, right? But I don't think it is showing in English. Let me see where I have gone wrong. Okay, now it works. So hope you seen the error. Um, so now my German language is converted to English language. Hi agent, hello. I hope you're doing well. To better assist you, fine. So this is how we are going to use the Cortex intelligence feature within Snowflake. And let me do so now we have done a translation. We will now do a summarization. So see, there are a lot of data available in this column. See, it has a lot of data. Who is going to read all those things, right? We are going to generate a summary of this information so that I can quickly see um, the main intention of this call conversion and wrap it up. So I'm just going to copy and paste in Snowflake Cortex Translate. I will use some summarize function, and here I'll just give the transcript and I'll remove this parameters. Okay. Okay, this should be in English so that I can. Okay, see, this has been a long piece of information. Conversation happened with the customer, but if I see the summary version, just see customer reported 10 broken extreme helmets with faulty buckles from mountain ski adventure. See, estimated arrival time within 3 to 5 business days. So this is how we are leveraging the AI tool to save our time and to increase our efficiency. So the second thing, the third thing will be classify text, right? So you are going to classify the text. Same, we are going to use it. Cortex instead of summary, we will use classify text, and here we'll give some list. Say it is related to food or it's related to cook. Sorry, let me just go and check the syntax. Classify text. So here you see I have passes Okay, let me use this example first. So if I run this, one day, just see the value I have passed here to classify text. One day I will see the world. So it's basically related to travel, right? So it is showing like this. So now here I will just mention this information is related to call, or this statement is related to travel. Let's see what it comes out. See, it comes out call, right? So it, you give any feature, any value, and it will tell you what kind of classification of text it belongs to. Let us say I will use one more thing, like some text. Let us say I love Snowflake, and let me give some context to it. Love or affection. See, automatically it has picked up affection, right? So these are the efficient LLM functions we can use within the Snowflake. One more is also I forgot, translation, summarization, classification, and one more is there, that is mm, complete. I guess I have not shown you complete. Sentiment and complete, both I need to show you. So let's go with complete. So now complete is nothing but it will generate some text around it, right? So let us say I pass this information complete. So now what it will let me just type this, write a article explaining about Snowflake, right? So this is related to prompt engineering, where I provided some prompt and I expect Snowflake to give some output. Okay, invalid function it is saying. Let me check the syntax. Complete. Okay. Mm, Cortex complete. Okay, the format I have, I think, missed out. Invalid argument it is saying. I think I should use some models, then only it will be understanding. Copy. So the model I will be using here is Cloud for Sonnet. Okay, if you see the result, it is now searching. It's extra small warehouse, so it is taking some time, but yeah, some credit is also getting consumed, so make sure you suspend the warehouse so that you can at least minimize the consumption of Snowflake uses. Okay, now see this output. It has given you a bulk of information. Snowflake are almost nature's most beautiful. Okay, I think it has understood in the perspective of ice and snow, but it's fine. See, so if I go and articulate this with some better context like data warehouse, something I will add the keywords, then it will be able to explain me on that perspective, right? I hope this explain you very nicely on the conceptual level. Okay, and I think one is remaining, the sentiment analysis. So select Snowflake dot cortex dot sentiment, and I'll pass the column for that. Let's say the same transcript column I'll pass, or let us say I just pass a simple text to show you, like I hate you. So what should be the sentiment here? Okay, again syntax issue, so let me go and check the syntax properly. um, Sentiment score. Okay, here. Okay, sentiment, I think I have gone wrong somewhere. Oh, Snowflake, snow. Okay, just a typo, apologize. Okay, now you see This is my negative point 8. So that means it is saying the sentiment is strongly bad. If I ask this or request here like I love you, then it should give me some positive, right? See, positive point 0.8. I am neutral, it should give me something, yeah, 0.1, or it can be considered as 0. So if I want to apply it on a bulk of records or in a batch mode, definitely I should attach some column to it, to a table. So same transcript column I will be using, and here I will give this from this table called transcript, and just copy and paste it. See, so hello agent, if you go through this, hi there, I hope you are having a great day. um, to better assist you, could you please provide your first or last name? Then customer is saying, providing first and last name, and then the conversation is getting started on some complaints, and then it is getting resolved. The agent is able to solve the customer query, and ultimately there is some happy note from agent side, and seems like this seems to be a pretty good conversation on the positive note, right? So definitely it has given some sentiment point 3, so you can see positive uh, values are there, so it's a positive sentiment from the customer side. So this help us in analyzing the customer feedback, so that we can process it and get a better improvised service, right? This is all business wants the same thing, so that they can run a smooth business over the decade. Okay, with this I think we have covered different LLM functions. So I will restrict this course till here. We will have another session where we'll cover the Streamlit applications. Thank you and have a nice day. Bye bye.